Welcome, Michael at Wickerson Studios. Basically, I thought I'd better do something a little creative. It's not hard to do creative acts, but trying to keep your mind around it and maintain a little bit of control is probably the trickiest thing. So what I've done is I've taken the work I've been doing in algorithms for dummies and taken the absolute basics of that and decided to grab the script that's just getting Numpy up and running in Grasshopper through Grasshopper Rhino remote. So you got to go in and you'll see up here I have all the stuff from chapter 4 that I brought in. Translating that chapter, I thought I'd start with the number 1 thing, which basically produces an array, a multidimensional array, a matrix of sorts. So, well, a matrix. And so then you can think of that as a tree system. Nothing fancy about the numbers coming in. And I ended up not liking the 0 that was output from this one, so I did instead I used the math functions on vectors, just the addition to each one of the elements, so I never ended up with a 0 element. So I took that and I brought it down into my script. And here's where it was applied right here. And I didn't end up using this after a while. This top one, I ended up using this bottom one. And I think I added 4 to it and used whatever rows. So I basically outputted a tree. So a big roundabout way to produce a tree from GhPython remote, but it will only get more complex when you start to allow yourself the freedom of working in scripting, say Python, along with your basic node scripting in Grasshopper. So after I get that up and running, I decided let's take a look at proposition 44, which is where I left off on Euclid's elements, to apply a parallelogram equal to a given triangle. And you have to produce a straight line, a triangle C, and a angle. So the best thing to do there is leave the turntable tool, go into top view, probably make it so it's just shaded, and you see the top view of this geometry of this thing that I've actually created. But I don't want to see all that. Actually, I don't want to see any of that, so I'll go to visibility off. But I do want to see what's going on in Grasshopper. So let's take it so we can view all the geometries that are happening. Now, I just want to see what I'm clicking as I go. So it probably, I have to do this again. I'll bring my face down here. I probably will make it so I can only see the geometry I want to deal with. So I initially went in and produced a straight line. And I've done this really basic and way too much work and too longer script than you'd think about to produce a straight line. So putting on a plane, generating a circle, generating points on that circle. I'll use shifts so you can see the plane, the circle, the points, the data between them, the lines drawn between them, the vectors drawn between them under vector display, the points at the ends, and the angle between it. So that's a long roundabout way of trying to get a line, which I then, that is the straight line that will then take this triangle on this plane. So as I go through here again, we'll draw this. The circle I've put over here so we can see what's happening. So the circle itself is generating 3 points. There's 3 lines on there to produce the triangle. The surface is there, and you have a centroid to that, and you have a volume. Okay? And I've actually gone so far as to put in all of these wonderful lettering systems of what's actually happening in this. So probably it's worth taking a look at the complexities of this script, because after producing that triangle, I want to go down and I want to produce a simple angle over here that I can play off of angle D. Similar way, vectors to produce that angle, and locate that as the angle D. So this all said, if you take a look at all this, you'll see I basically to this point have my triangle, my angle, and then from that line I want to extend and produce a parallelogram, which is basically what this section does. And what's nice about that section, before you get into any of this funky donkey work over here, which is all about building a geometry, is you want to get your head around this script that you can actually produce a parallelogram, multiple parallelograms, that from these sliders you can change your triangle and the area of those parallelograms maintains the same according to the triangle that's there, and it actually adheres to the angle that it has to be consistent with, angle D. So that's really the device of actually controlling the geometry, and that's probably the most exciting thing about here, because that's Euclid's, that's basically a script that will show you Euclid's 44th proposition in book 1. And then, after that's said and done, I really am going up into the perspective mode and saying, what do we do with that geometry? And I ended up grabbing Numpy, a grid of points, orienting those points to those grid of points, doing it within a circular cell, and then allowing myself the ability to move those geometries up. They don't need to be surfaces. I just did that for fun, because then I simplified them to the breps and boundary edges and took them through a loft and ended up with these 4 loft forms. So that's it, and that's how you end up with this device here, and you have this kind of geometry that is fully parametric through an array or multidimensional array that's coming out of Numpy that's already generated by Euclid's 44th proposition. And that's how things go. And when you start thinking this way and your mind starts wrapping around this, your possibilities are endless. You can end up associating this with architecture, with sculpture, with jewelry, with design, or whatever. It's not that complex, and I'll probably break it into parts, and I'll show file, open, the initial stages of, let's see, desktop, G2, cancel. I want to file, open. I think it was on my desktop. Oh, I'm lost in here for a second. My PC. Hang on a second. Desktop. Why am I losing my mind? Is it because? That's just part C. Am I locked into something right now? File, open. Sculpture. Desktop. Oh, maybe I was. Oh, I'm ringing my phone right now. I'll have to take a break once. Oh, I've pulled up the first 2 scripts, A and B. I think this is A. It's always so tricky. Pull up A. So this is basically the geometry that was driving that. So this on hidden. Take a look at top view. And here it is. I'll run through this script first, which is basically the control, as you can tell, of the area. The area of the triangle over here will always match the area of the parallelogram. So that's kind of nice, no matter whether you change the angles or move the vectors on the angles. And then the B, I go into a little more complexity here. I just twin it. Actually, I don't twin it. I use the medium here. I actually go through the actual process here of actually using the diagonal line that's moved in the same direction that you can actually match these 2 parallelograms. So that's kind of exciting. And then I also label everything at this point. You can see that everything's labeled A through M. And then back into the final geometry where I'm trying to apply it to a little bit of applying this geometry to something a little more interesting right here. So you can output and produce some cool geometries to do something with. And, you know, it's pretty fun to think about things that way. Maybe you never did before. Nice little models. And that's it. An application of using Numpy instead of tree data. And the more complex you want to get with that, you can get. And so what I'm going to do is I'm going to keep digging into it, move past these Booleans to test matrices, or test, let's say, trees, to see if they're actually similar throughout. So you can see 1, 2, 3, 4, and 2, 2, 4, 4 are going to come out false, true, so you can use those to call points. And we will keep eating through all of that to get into, and I should be numbering and naming these a little differently, what was the thing I was doing here? Performing multiplication, and then getting into really the details and breakdown of what's happening, I think, in dot. Oh, this is just ways to reshape functions, to transpose matrices, to discover the inverse, and use the all close and compare dot product functions. And as I keep going, I will keep trying to apply NumPy to all of these things. And what's nice in that as well is I can always go back to chapters 5, 6, and 7, which I completed. So chapter 7 is going to have to load up here because I'm using Python GhPython remote. You can see that here we start getting into a little more complexities, and we build an entire matrix class in the end that can do an awful lot of things for us, and I'll customize that as well to actually pull out data, pull out different trees, have much more control over it, start playing with different data as well, and show the visibility of what's actually happening in dot product, and break down things like grafting and flattening and simplifying this way through GhPython as opposed to the Grasshopper 1 path mapper and other tools for understanding sets. That's a lot of information, I know, just to get some simple geometries, but I find it exciting. I think the applications of what can happen after you do this will be exciting. We'll stay very basic to start, and in the end, we should be able to even surprise ourselves with what parametric control can do for you and produce. Thanks again for watching.